Hey, Joseph. Hey, Crazy. Buurman. Hey, Joseph. Hey, Chrissy. Okay. Is it possible to have some sort of overview? Maybe using this one. Periscope with this one. Sorry, people. Okay. That is my entire screen. Cool. Can you hear my audio? Like a check. Put this one in background. Okay. Perfect. Thanks, Joseph. Okay.
Joseph for me.
Sorry?
Say hello to Joseph.
Oh, say hello to Joseph from Sylvia. I bought some new gadgets last week at Tinytronics. Thanks for the audio heads up. So I saw online that the M5 Stack shop had a holiday, so they are not shipping anymore. And in the Netherlands, in Eindhoven, you can buy them, so you don't have to wait long, like next day delivery. And today I discovered that P. Maroni is also shipping. Sorry, shipping the M5 as well. So that is a lot better than it used to be, as I initially had to wait for my gear, like sometimes over a month. So what is it that I have bought? So let me show you this one first. So I hope that you like me showing it to you. So this, and I maybe need to up the microphone a little bit. Make it a little bit more clear. So this is the PM25 sensor. It's a particle monitor. It's on the back of this M5 stack. So this is the Bitcoin foot. So it's like for a ticker tape that you can put on here. And the old one was like just putting an M5 core or Fire on the back of it, but this one has like a particle monitor. So there is some stuff built in. So if you look at the bottom, where is it? Sorry for making you all dizzy. There's only connections here, there's no circuitry. So let's wait a little while. Looking at the stream myself, and it's, yeah, I think M5 stack has replaced Arduino, because like the ecosystem is so much easier. There are so many new stuff coming up, and it can be used like as a child, it can be used like for infosec, it can be used for tinkering, it can be used for DIY, it can be used for artificial intelligence. So many different directions. So I want to show you this one, and if I show you like the other one, the old one, you will see that there's like a blue sensor on the bottom. So I don't know which one this is. BMP 280, I think, maybe another one. This just adds a temperature and pressure meter to the I2C bus. Well, this one has like more advanced. Oh, DHT11, yeah. Thanks, Joseph. So don't know what all the numbers mean. I just downloaded the stuff from Git and uploaded it. So yeah, it works quite well. And while my kids are upstairs enjoying themselves playing games, it's hard to get them downstairs for dinner or breakfast or whatever. So I was thinking about just having a couple of these and let me show you something else. Original. This is the piece that you buy. That allow you to create like a network, so you can interact with the kids, and they can interact with you without having to leave the PC. But you can also use it like to measure the temperature. You could even use it like for triangulation on which or see which phones are registered to the DHCP server, what Bluetooth devices are nearby. So there's a lot of possibilities that you have. I need to share one more thing. With the Telegram group, I seem to forget that all the time. So some people ask me to create a Telegram group to allow people to register to it to see if there's any news. So you don't have to follow me on Twitter, you don't have to do all the other stuff, but you can just see in Telegram if something is going on. So that's the temperature sensor, the particle, the air quality measurement. So there's another component, this one, and this is a carbon dioxide sensor, so a little hard to read, to see how the carbon dioxide levels are in your room. And this is not an M5 component, but it should be possible to turn this into an M5 component. So yeah, see if I can either make some external connections to it or build it into one of the proto devices. But this is something that Joseph actually inspired me to buy, and yeah, it's something that I would like to work on. There's another one. There's this one, and this is a piano shield. I think it's easier to show it on the webcam. So you see on the top there's neopixels, so addressable LEDs. So you can set each and every one of those pixels to your own color. And there's buttons like capacitive buttons that you can press. And like on the side there's some pins. And I hold it like this, M5 piano. So what you do is if you have this is a fire, so this is the most advanced M5 stack up till now, and it's the red one, and it has 3 growth connectors. So there's one, let me show it on the other side. You have to remind me switch the scenery sometimes. So there's one here, and there's also one here and one here. So the unlabeled one is the connector A. This one is the A, and you will see there's 2 waves. So these are like the variable pins. It could be RXTX, could be GPIO, could be I2C. And there's a minus, so it's the ground pin, and there's plus, that's the VCC pin. So this connector A. Then here we have a micro SD card. And here on the side you will see 1, 2, 3, 4, 5 LEDs. So you're able to make it shine or make some sort of pattern. And this is B and C. And you can configure each and every port to be whatever you want it to be. So you can have like 1 serial and 1 I2C, 3 GPIOs. So that's something that you can configure, and it runs on. Dankjewel Bas. It runs on USB-C. So some modules have a battery built in, and others don't. But there's the other one. So this is the M5 stack W Rover, and the black one and the gray one are the core ones. So one is the fire. So this is actually putting them in order. So the black one is the core, is the W room. The gray one is also a core W room, but it has an extra sensor attached to it. And the red one is the W Rover, which has more capabilities. But you see that the fire has a growth connector, so it's used for adding all these sensors to it. So there's like I have a box of cables. These are growth connectors, and you can just hook up every component that you want. So this is a laser module, so this allows me to set up communication via Laserbeam. So there's a laser pin here, a laser diode, and I can just connect it like this. And this is how you hook it up. So the device itself, and you can compare that one with an Arduino, and a module that you can hook it up to, and you can make it do whatever you want. Fire and GPS. Yeah, cool. But I have a separate GPS. Do you have like the GPS bottom or the external GPS? It's like I have this one myself. This is the GPS external module, but they also have like a bottom for it. So you can stack it, and that even allows you to attach an external antenna, as far as I know. Okay, yeah, cool. So Wiggle will be happy, I think. So as you can see, like the Fire has no pins on the side, while the Core has pins on the side. So if you look at the bottom, you will see it comparable to an Arduino. There's a lot of pins. So there's like 3, 1, 16, 17, but there's also reset and battery and 3.3 volt and 5 volt and ground, and like all around you will see like different pins. So these are 5 volt 3.3 ground, SDA and SEL, which is I2C, and MOSI, MISO, and clock, which is SPI. And on this side you see analog, digital, digital, analog, and some other stuff. RX, TX, 0 and 2. Is there also a 1? Maybe on the top? Left? No, don't. I only see 2. But you can all look those up in the datasheet. But the these bottoms, so like I can remove. Is it possible to remove this? Yes, it is possible. I can remove the bottom. So make it a little bit. So this is the bottom of the device, and let me tear this one apart as well. Come on, you can do it. Yeah. So now I have the bottom of the black device. So I took those apart. So this is the small one. And you can see the chip inside, the ESP32. And this is the bottom of the other one. So it has a large battery inside, and this is even a special one, since this also contains an 13.56 that's high frequency RFID antenna. I think it's a 522 that's built in. So I can also stack this device, the black one, to this one if I want to make it use more growth connectors. And you can also buy these bottoms separately, but usually when you buy a Fire, it has like the bottom with the LEDs, and there's a sensor in there, and there's like 2 extra growth pins, while the Core usually has like the pins all around for tinkering with them. So there's one thing that I find odd on the M5 stack. So if you turn it on, you have to press once, and if you turn it off, you have to press twice. So I had to look that up the first time that I used it. So here you see like the pins, and there's like holes on the side, and if I connect the pins to the holes, you see, whoop, so they are connected. And if I turn it on, you missed the animation. So so this is not like high-end audio, but still you can make like a tune. And I put this one on Twitter, did not have any reactions yet. Don't know if anyone recognized the tune. But this allows you to have like an interaction, and don't know what the price of this module was. So M5 stack piano. Let me switch to the other one. Screen. So store. Application, I think this one. So it's like $13.95 for a piano extension to this device. So this is like really cool stuff, and as much as I am a fan of Lego, this is a lot cheaper and has like much more possibilities to work on them. And it even works with the Lego sensors. So there's like connectors to address the Lego servo motors for it. And is the PM here also? No. Oh yeah, the particle. Particle is a little bit more expensive due to the sensor. Okay, so that's the piano, and these are pre-flashed, and if you want we can build it ourselves to see how that works, how the internals work. I'm shipping stickers to people, and I have different scales. Let me see where they are. So I buy these at Action in the Netherlands, for instance. But one of the problems I have with these scales is that they switch from unit. So one time it's like grams, the other time is like spoons, inches, cups of tea per banana. It's like at one moment in time I put too much stamps on them because it was on the wrong setting. So I thought, well, I want to have like a scale that is just simply doing its job, and was quite hard to have like something that's easier. So I run into this one. Oh. This one. And this is actually a unit to create your own scale. So let me put it back to the microscope. So what you see here is like, this is an industrial weight sensor. It's a little bit hard to see, like the metal part in the middle. And it needs a conversion from weight to I squared C. I think it is I squared C. GPIO something. HX711 is the sensor they are using. So we already spoke about the core and the fire. This is another one. This is the stick. So the stick is like a small M5, and let me turn it on. So scale is initializing. Zero. So what I can do is remove this, put it here. So this set. If I press this one, it will set it to its default value. And if I put a unit on top, it will measure it, and this is like 60 grams. So this is the device on top. A little bit hard to see. So if I press on it, it's capable of handling 20 kilos on a gram basis. So if you want to put this one into something that's able to use different units, you're also possible to do that. But this is another device. This is also an ESP32. However, this one has just a few pins. It has a microphone, an LCD, real-time clock, 6 axis, a battery inside, and one Grove connector, and it is powered by USB-C also. And there's 3 buttons, a power button and a button here. Don't know which one. Oh, there's 2 buttons, G39 and G37. So yeah, this is something you can use as well, and they used a M5 stick, that's the name of the device, but you can also use like a core or a fire or an atom if you want. Well, atom might be a little bit hard if you only have a resolution of 5x5 pixels. So that was the second one. What else? What else? This is something fun. So this is an accessory. So that's a module or accessory. Where did they hide this? Unit. Okay, this one. So let me put it on the other screen. So this is an device that allows you to do AI recognition. So let me see. Facial recognition, object detection, containing size coordinates of target in real time. Video recorder. So this is, I never worked with artificial intelligence before, and I thought this might be fun to get me started. They have 2 devices. So this is the separate module. So just a camera, and does it have a, yeah, it has a card slot on the bottom. 5x5 display for AI. Yeah, that's easy to recognize. There's a 1 in 25 chance that you're correct. But they also have this as a module. That's an ESP module. Let me see. I think it's a stick. this one. So it's not much more expensive. And this contains the same camera, but there's also an ESP connected to it. However, it does not have Wi-Fi. And if you're using the device with a separate ESP32, you can do something with Wi-Fi. At least that's what I presume. But I have to, sorry, 5x5 scale. Oh yeah. Yeah, there's quite some lag in this one. For some reason, let me. Oh. Okay. What else? So the laser might be fun. So this is 2 components. So that's a laser works like this. So these are the 2 connections, and you set them up like this to be able to communicate. So you can do wireless communication using light or using laser. So wondering how that works, and if you look at the price of these, I think that's always interesting to tell you what the price is of certain things. So store, laser. So one is $1.90 and the other is $3.75. So it's quite cheap for sensors to fiddle with. And there's some stuff that I want to examine, and this is about not as much about ESP32, but it's about protocols. So I bought PLC modules. So this is a PLC module. I don't know if it is visible or not. We can try and set 2 devices up to see if we can somehow create communication and see if we can make it visible. So if it's like laser or is like infrared. They call it laser, so I think it should be visible. But I have not tried it. But the reason of getting the stuff is like for fiddling with it and see how it works. So let's see how we what we can do later on. So this is the PLC module, and it has 2 possibilities. So you can connect it using a magnet, which is connected to it now. And the other solution is to use like these brackets to put them on a rail, like you have with the normal PLCs. You can just connect them, click them on a rail. So take some pressure to get off, but this is the connector, so you can screw the connector. So either select magnet or rail clip, and this is something that works like this, and now it's stuck. And this allows you to do some stuff with connectors. So I do not have a lot of experience with ICS, SCADA kind of stuff. So a friend of mine was so kind to give me PLCs that they disposed of at his work. So they cleared all the remaining programs in memory, so there was no data loss of some sort. But I was able to like fiddle with these PLCs. And then I saw like there's all kind of different protocols that are used on these PLCs. So where you have like a serial port, a parallel port, USB, MIDI, which is like something that you would use on a computer. You will see like RS422, RS485, sometimes still RS232, and yeah, these PLCs work like a bit. The brand was a Siemens a 300 series with some extra modules, and yeah, that's something that you can get your hands on Craig's or Marktplaats or whatever to obtain like the old stuff, especially when they replace it for the newer stuff. So this one is closed, so let's open it up, see how it works. We should always see how stuff works. So there's like these. So when you buy these, there's no connectors. Yeah, absolutely, yeah. And especially if you like set it up. Might be a little hard to get your hands on the programmers or on a PC old enough to run the software for the programmers, or get it running on a VM. But still a lot of fun. And there's another thing that's cool. If you want to fiddle with PLCs, there's some device that you can use to sort of have a USB PLC. Forgot the name. Let me see if I can look it up while you are able to look at this stuff. Okay. Let me search. Where are you? PLC. Actually, I have a lot of emails with PLC. Order, maybe. Ace Automation, that's what it was. And this is really cool, and it's quite affordable. Like the device that I bought. The software for this one is for free, so this is actually very cool. It's aceautomation.eu. So let's switch to this one and go to where are you? Screen view. Yep. So this is the device, and you have different models. So you have like this model. Just clicked on it. So there's different models. They also work on a rail, and it connects via 2.54 connectors, and you can program it using their software. You can even already fiddle with it without the device. So you can program it in ladder, and you can program it in. So this is the builder stuff. Ace Automation builder. Might be some. So here you see like this is some flow, and this is some ladder. So this is allows you to get acquainted with programming PLC. So it's not the same as a Siemens or a Mitsubishi or ABB or whatever, but still it gives you an idea on how it works, and you can fiddle with it in like an M5 stack or Arduino kind of way. So I have no idea how they, if there's like already an ecosystem for building PLCs or doing so, or it's just like a large state machine that they use for building this. But like from a hacker's perspective, most of the detection on securing ICS environments is built on the network surface. As from a breach perspective, that's like the easiest way to get in. So if you are in network, you are able to connect to the PLC and do like all your rogue stuff. People, please don't do that. But there's also the other side. So all the components are connected to each other, like via Modbus. So what if you could add something to the Modbus and manipulate the serial stuff? Then the PLCs would still be normal. Network traffic would not show up everywhere, but still sensors are overwritten or actuators will be addressed. So that was my idea, like as a proof of concept to build something like that. But back to this unit. Microscope. Okay. So what you see on one side, there's this board, and I soldered this board on top. I think I even have an original board still lying around here. So this is how you get them. So this is for, am I able to read what this is for? Hardly. But this is for RS485. So I have no idea how this works, but I do have a telephone here. So what I will do in simulation. Yeah, cool. I would really love to see that. Your setup. But having like the physical stuff and having like a piece of wood with PLCs screwed to them, and like a fan that you're addressing, or yeah, anything else, making it visible, making it possible to actually see stuff happening, other than having a VM that will show that something is wrong, actually gives more impact. Like at my office, we have a train demo, which is inspired by Stuxnet. So there's S7 1100, I think, where you, yeah, where someone carries a USB stick around, puts it into a office network, and by pivoting from office network to control room, it's able to ARP poison the environment and sets up like a remote desktop. So it's not entirely Stuxnet, it's inspired by Stuxnet, but still seeing the trains crashing will give more impact than just showing a virtual thing. What I want to know is what chip they used for this device, as I just buy it. I miss my microscope. Really hardly readable. Maybe add some light to it. Maybe use an angle. Always helps. We have like the stereo microscope at the office. That makes it easier to read stuff. So now I need to write it up myself. Where's my notepad? Notepad. Okay. SP. Go on. 4, 8, 5 EE. So SP 485 EE. Okay. Datasheet. Okay, the Mouser is probably a better one. This one, yeah. Thanks. Is there like a link to, yeah. Come on. Date sheet. So the SP45E are a family. Are you able to read it? No, you are not. So I need to switch channels again. Okay. So family of half duplex transceivers that meet specification are RS485 and RS422 serial protocols. Okay. Features 5 volt only, low power. What's the drop? Okay. So how does this work? So you have on one side VCC and ground, and you have an A and B, and I have no idea how this works. So that's cool. test circuits. Driver input. Okay. So this is not helping me a lot. So somehow this is connected, but I have no idea what these receiver output. Receiver output enable active high. Driver enable active high. Driver input. So I guess that's like RxTX, but in RODE style, that have an enable to make it work. So that's at least what I'm assuming. The VCC needs to be between 4.75 and 5.24. So this one works on about 5 volt. However, I'm powering this device on 15 volt. So input voltages. So the logic absolute maximums VCC. So there must be something in front of it. I see some capacitors. Yeah, actually what I want to do is measure the signals of RS485. So there's multiple ways that I can do it, and one is where I have this stick. This stick has like a USB on one side, because this data sheet I simply don't understand. So go back to the microscope view. So this is a USB stick on one side and has like all the internals to communicate via, I suppose, a FTDI, via conversion to RS485. So if I insert this, it will pop up a COM port, and if I connect PuTTY to it, it will transmit the signals on this device via RS485. So let me get a USB. So I inserted the stick. So now I will go to PuTTY. What do you have? Maroon? In regards to your message, I have them. So what I need to do if I want to know the communication port is go to Device Manager. So type Device Manager, It's on my other screen, but I will share to the left one. So this is my device manager. Go back to screen again. So this device manager, and go to ports, and there's a dongles. The RS485 dongle. So this is USB CH340 and it's COM port 10. So we know it's COM port 10. So make a note of that. COM port 10. So, oh. So what I need to do now is start PuTTY. So this is PuTTY. Go to COM port 10. And now set it to a specific speed. It doesn't matter really. 9600. Set it to serial. Go to the serial port. Disable flow control, as it might bother you on a later stage. And then open a connection. And now you will have a window. I made it a large font so you're able to see it. And if I type something, nothing will happen on my screen, since there's no remote connection to it to echo the data. So if we want to make that happen, we go to change settings and go to appearance, no, behavior, no, translation. What is it? Terminal. It's terminal. So go here, terminal, local echo, force on, apply. So if I type A, I will see A's. So I know that I'm actually doing anything. So I'm sending now, and I'm actually making a mess here. Oh. Is there another way that I can fix this? No, not right now. But there's like, I get this one separately. So this is the connector, and there's some DuPont cables here on the end. So what I'm going to do, yeah. Thanks for explaining, Maroon. Is it Maroon or Arun? Because I see your name different on different channels. So what I'm going to do now is this is a other side, and turn the light off. You're able to see it. A very cheap, very tiny voltmeter. Ah, Arun. Yeah, thanks. Was wondering about it. Okay, then I can address you properly. Okay, so what I need to do is I need to somehow get these connected to the pins. So I should have some alligator clippings. Not here. Maybe here, like another box. Oh, what I can do is use these This is something that I created. This is a tiny USB hub that you can hide somewhere. So, I don't know if you're able to see it. Like all the components are soldered together to make it as tiny as possible. So there's a clipping next to it for scale. It's like a red team stuff. Okay, so what I'm going to do is I'm going to connect a female connector. So yeah, I can switch to the other one. Yeah, let me do that. Thanks, Joseph. I keep forgetting that. Okay, so this is, and now probably you want to see this one. So this is like a USB hub that I took apart and removed the circuit board and soldered all the components together to make it possible to hide it somewhere. Okay, so I'm connecting the cables, I'm connecting the pin, so we have 2 pins. Yeah, I'm actually waiting for the camp zone badge, which is like a device that allows you to make macro buttons. So this allows you to clip. So I can clip this to the pins. So I'm clipping the chip for the USB up. I don't know. I just bought a cheap one. I think I paid only €3 for it. There are some people that are selling micro USB hubs. Unfortunately, I'm not able to see it, as a lot of these components are on top of each other. So, but it was a generic chip for it, by the way. This is not smart what I'm doing now, because I'm already connecting it while I did not set up the multimeter. So this is the scale. So if I set it to 0, it's off. This is for the continuity test. And if you look here, you see a diode, and the diode is next to it as well. It's like the triangle thing. And there's also Wi-Fi on the right. At least I keep calling it Wi-Fi. It's an audio sound. But if I say this multimeter needs to support Wi-Fi, people will remember. So if you set it here to the continuity test, you have to press func to make it into the Wi-Fi setup. And if you connect the 2 pins, sorry, hard to make the sound. I hope you can hear it. But that allows you to do tests on devices where you don't have to watch what you are doing. So you're able to just listen to the audio and then see if a pin is connected to another pin. So I'm taking the connector out again because I want to know something. So what you see here on the bottom, and that's something that I'm going to document on my page. Oh, thanks. So the RS485 dongle, so documentation is key, has a B, which is D minus and has a which is D. Yeah, I saw already some stuff, and I heard some hacker spaces helped creating the special frames to it. Hey, I'm Willem. So I have these two. So the A, which is D plus, is connected to the red one. So red, and this one is connected to the green one. Okay, so I can put this one back. And now I'm using the red one here. Let me do the red one on red. And I have no idea why I do it like this, but let's just full YOLO this one. So these are connected. But you're not able to see the oh, Yillus ass. Okay. Do not connect voltage when your multimeter is. No, wait 3 more weeks. I should connect this one like from continuity test to ohm to voltage. So it's now set for voltage, and what you see is like the meter is now auto sensing and it's set for millivolt. And since it's like floating or very tiny, you will see some signals, but in fact it's too low to really be any use. So what we see now is 4.88 volt. So I have a 4.88 volt. When I connect the red to VCC and black to ground. Okay, so the other way around, if I connect the red one to the black one, now we see a, sorry, you did not see that before, a negative value. So there's minus 4.88 volt when the black one BLK to VCC, and we don't have black, it's green, green and green to VCC, green to VCC. Okay, so that's an interesting one. Although we do not have a and I need to show the other screen. So screen view. I removed the device, I think. So let's restart the session. So what happens if I type values while measuring? So go back to the microscope view and maybe I should select a window before I type stuff. I actually see the value change. So from 488 to something lower, and if I type like H, I think I see data, but can we make it more visible than using a voltmeter? So I do have a tiny oscilloscope, a cheap one, a DSO 112. So taking this off again. So removing the voltmeter. And what we learned was that the red one was in fact VCC, while the green one it's on active high mode REDE. Can you explain that? So the oscilloscope is connected, and you see on the bottom it is set to 1 volt. So each square is 1 volt. So that's 1, 2, 3, 4, 5 something volt. So what happens if I start typing on the screen? A bus can be either low or active. High means no data. There's a pull up, pull down. Ah, okay. Just like GPIO. And how is that called? While I type. Yeah, but the name of the setting for RS485. Active high is what you're seeing now. Okay. Yeah. So this is active high. And is active high like the default for 485? So you can see, like, whenever you type something, you will see it being put low. So am I able to somehow read this data? So I did not prepare this. So what I'm going to do is www or just Pulseview Secret Pulseview download. I hope this will not restart the. Do I have Pulseview? I don't think so. No, I do not have it. Okay. Yeah, that's what I'm going to do. So I'm going to install Pulseview to be able to read the data. So download OS specific instructions. Go for Windows and do a YOLO nightly build. So it's downloading it here. Okay, keep, harm your device, I don't care. Run anyway. YOLO. Okay, so let me show this one. This is Pulseview. Next, next. Examine data. Next, install. So this open source logic analyzer. So it runs on a lot of different devices. I do need some stuff for this. I need, yeah, yeah. I'm waiting for the blue screen of that, but it's like did not sacrifice Henky to the demo gods. I could need this one, but what I at least need is the firmware files. So, okay, where's the firmware files? Come on. Example files, firmware. This one. Git clone. Downloads. Firmware. Windows. Are these already installed? Maybe. Pulseview. Yeah. Okay, so this is Pulseview. Now I need a crappy not in this box. Okay. No. Yeah. So this is my. I have no idea where my OBS is. It's here. So this is my logic analyzer. So do I have a proper cable? This is micro USB. This is no, it's not battery powered. It is possible, and yeah, it's easy to see if you have like signal, but it states that it is battery powered, but it is not. But maybe mine has a broken LiFo. Need to open it somehow. So there's mini USB on one side, and there's pins on the other. So I'm going to connect this, and you see one LED to indicate that it works. And you can buy these off Banggood, AliExpress for like 10 euros. Okay, again, there's one thing that you have to keep in mind. No, I need the firmware. That you need to connect the logic analyzer before you start this. I don't know where they moved their firmware files. Replace, get open source. This one. Pre-build. Yeah.
Oh, goed.
Latest ones, and this is 1.17. Okay. Okay, this is a little bit of a hassle. Oh, sorry for not sharing my proper screen. So screen view, where are you? Here. So I went from the pre-built firmware files to the download, and I took the latest one, and this resulted in a download somewhere. So let me look where my download is. Date modified, more apps. 7-zip. 7-zip, open archive. Okay. Okay. So I opened the tarball, and now I need to open the file on my hard disk. It was 74, so let me search where it is. Probably Sigrock. Where are you? Should have paid closer attention. Git ASET was maybe if I go to Pulseview, go to the app, right mouse click, open file location, properties. Oh, I thought I downloaded a 64-bit, but it seems to be a 32-bit. So programs 86, and now I go to Sigrock, and now I go to Pulseview. So where my stuff is, and I need to hardware include. This looks like binary stuff. I thought I was downloading. Okay. So go back. Sigrock. Ah, there's source in the top. I should have read that. Okay. So source binary. I needed to select the second one. So binary 1.7. Open file, more apps, look for another app, 7-zip, 7-zip file manager, okay. Okay, so this is the Sigrock file, and this is the binaries. So what I need to do, now I need to go back to the other window. So this is Pulseview, and I copy this one. Hello. here. Continue. And I'm renaming this one firmware. So it's not very user friendly, but now I'm starting Pulseview again. Pulseview, and it does not work. Why doesn't it work? Program files. Yeah, you could run logic, but I think it's more ethical to do the open source version. It will be possible to run logic, but I think that if you're running logic, you should buy a Salea logic analyzer. But I want to show how Pulseview works because I think it's a pretty decent piece of software. And they have grown over the years, and they have a lot of support for different protocols. Where is my... No, need this one. But I myself have a Salea at the office. I have a DS Logic, which is based on Pulseview as well. It's a 16-channel logic analyzer, and I used to play with 0 plus, but yeah, not my cup of tea. Sigrok Pulseview firmware. So why is the firmware not here? Do I somehow need to configure where my firmware is? Share. Oh, okay. So what I did is they actually made it a new directory which is called share. So it does not need to be in this one, but I need to go to share firmware. Pulseview firmware, Ctrl X, go to share firmware, Ctrl V, move. Yeah, sure, replace it. Okay, now these are connected, and if I start Pulseview again, so it's fun seeing me fight with all these okay, where's Pulseview? Here. Come on. Why isn't it recognizing the devices? Okay. I think it's actually this one. Scan for devices. If I remove it and put it back in again. Come on. Pulseview. Device manager. remove it. Oh, the device is not recognized. Okay, so if I insert the device, it is not recognized. So update driver. Browse my computer. Say no. Update driver. Browse my computer. See program files x86. What was it? Sigrok, I think. Sigrok. Okay. Next. No. Why isn't this uninstall device? Okay. Reconnect it. Unknown device. Why? Just like a crappy Pulse. Why isn't this working? Okay, let me get another cable. See if we can fix this somehow. I have a different cable here. Another logic analyzer. In the hallway now. you still enjoy seeing me work. So inserting this one. And I did bring a red cable. Where are you? Here. So this cable was included with my makey. And as you can see, the comparison of the cables. Where are they? Here. So the red one is a bit thicker than the other one. So connecting this one. Okay, starting Pulseview. Does not work. So what am I doing wrong? Trace view. Maybe I should read the manual instead of just... Okay. Download. Pre-build. Pre-build firmware, that's what we run. See above. The latest. You can also make them yourself. Build Zigrook. Yeah. Should work, but it does not. So, okay. Now, I still want to have this working. I really think it's lame to not make this work. Especially because you bought one, Chrissy. So we should make this work. Okay. Scan. Show hidden stuff. Unknown device. Update driver. Oh, this one is not connected, this one is connected. Remove this one. Install device. Show. Where's the rescan? Scan for hardware changes. Mini Pro. Arun, you're a hero. I forgot the Zadig step. Yeah, I have this configuration. Oh, this is amazing. Yeah. Okay. To make this work, you need to install the Zadig driver. And the Zadig driver is bundled with your installation. So you have to start the Zadig. Yes. Okay. And now it needs to recognize the device. Yeah, you don't have this shit on Linux. So list all devices. What do I have? Should have like some unknown device. FaceTime. Wait. You're right, Joseph, you're right. Okay. So what do I need to do if I reboot? I'm probably losing all my okay, do I still have video? Yeah, I still have video. Okay. And if I start the device manager again, device, this would be, and now I have an unknown device here. Okay. We're getting there. Now I'm starting Zadig. Okay. Zadig will recognize an unknown device, and we need to configure that unknown device as Win USB. Install driver. Come on. You all having fun? Working on your Linux like real hackers? Okay, I can close all this gear. So important steps, like 1, download Pulseview, 2, download the binary firmware, put the firmware in the share directory, and run the Zadig driver. Okay. Yeah, I can imagine it does. You take the right tool for the job, yeah. True, true. Okay, this is installed. Now go for Pulseview. That's true, that's true. I'm streaming this from my Macintosh that's running Windows and has like virtualization on it, but also using Proxmox with virtualization for home server and yeah, and sometimes like I have this EEPROM programmer. The software was working better for Windows than for Linux. So Pulseview, where are you? Come on. Pulseview. So this one is restart. Okay. And there should be, oh, that's always good. Generic error. Pulse. Okay, now it is working. So it recognizes the device as an Salea device, and what you see here is on the top left you can add a session. These are all your pins. So although there's let me show this one. Where's my I think I need to reconnect. This is the webcam, that's okay. But the microscope is not working, is it? No. So can I deactivate it and activate it? Will that work? Yeah, that will work. Okay, so if I switch back to the microscope view, so you see 10 pins, and like the CH0 is the channels, to CH7 are the different connections that you have for doing the logic analyzer test, and the bottom two are ground pins. So if we are going to connect not going to try either Logic's the port or online. No. No. Yeah, that's the same as like doing software-defined radio on a virtualization. I will not go that way as well. I always do that native, otherwise I will go mad. Totally insane. So what we did discover last time is that the green one was set to ground. So if I'm setting this one to ground, and the red one was set to signal, so I'm sending this one to CH0. So what I'm doing now is the D0 has the red pin connected, so I'm coloring this one red as well. And what I'm also going to do is, if I click here, I can disconnect all the pins that I'm not using. So I'm only measuring the D0 pin. Okay. If you know how it works, like there are some basic principles, it is very easy to use. It's like a lot more easy than what is the name of the other thing again? I think Salea, like the logic, is also very good. Oh, I might want to switch screens. Now let me do that. Thanks for reminding me. So that's a screen view. Hope you're able to read what you see. So this is the logic analyzer. This is the number of samples that you have, and this is the frequency that you scan it on. So what you need to do is, if I'm setting this one to 1 megahertz and I'm scanning 1 mega samples, this means I only have 1 second of data. While if I set this one to 100 kilohertz, no, not sump, 0 plus. I find 0 plus confusing, but I think it's either because I was used to other stuff before, but it's not as intuitive as Pulseview or Logic. So depending on the protocol that you're reading, like say I'm setting this one to 24 or to 16 megahertz, and I want to have and I set this one to 1 mega samples, this means you can divide it to each other. This is 1/16 of a second of data. So if your Pulseview quits rapidly, you have set stuff up wrong. So I'm setting this one to like 100 mega samples, which means 100 divided by 16 is like a little over 5 seconds of data. So this one is connected. Now I'm going to, it's connected wrong. So setting this one to ground and this one to CH0. And what I'm going to do is I'm going to start this while typing the letter A. Run. So this is my data. Is it? Maybe set this a little bit longer. So 200 mega samples. Run. run. This is very short. Run. So this is my... You need to scroll right, yeah, but I do not have any data. So am I able to somehow send data in a loop to this device? This is connected? Yeah, it is. So set this a little bit lower. Run. Okay. That D should be so there's data here. So these are the bits that it has read. So this is basically a voltmeter that has the domain time connected to it. So this is not more than something that's able to record voltage over time. So what it makes special is like the possibility to add protocols, and this is the button to add protocols. So you can search here for, and I have not seen this interface before. So I'm searching for UART, audio, automotive, display, embedded industrial, UART, Modbus, okay, this is Modbus. Requires you to input type, okay. So I'm first typing UART, and if I connect to UART I can select the pin. So the pin I'm using is D0, and D0, this allows me to stack a decoder. So now I should be able to stack Modbus to it. So this needs to be configured. So this is configured for 115200, and if I go to this one and I look at the settings, then I see that this is set for 9600. So they need to be matched, and you can see here that these are the bits that it expects, and these are the bits. There's one thing that is a little bit annoying here. So these are the bits. So this is like 1, 2, 3 zeros, 2 ones, or no, 1, 1, 2 zeros, 2 ones, and a 0. And this is what it actually sees. So I need to alter this. So I'm going here and set this to 9600. And this will state that this is the start bit, and this is the data that has been sent. So am I able to interpret this one? So I'm setting this one to, it's now set for Modbus. I should be able to, let me remove Modbus first. Data format ASCII, and now you see a D was typed. So this is actually the D that I typed, and was able to capture just one D. Are you with me, Chrissy? While I drink a sip of water. Don't know if Chrissy is still... Yeah. Oh. So it's really straightforward how it works. But what I see is that even though I do not have a Modbus selected to it, I'm still able to interpret it as UART. I recorded it as 5 volt, so I measured 4.88 volt. So what I was wondering is, am I able to capture this signal using an FTDI? Anyone suggestions why this should or should not work? Oh, enjoy, man. I saw that one. Cool. Thanks for joining, Jan Willem. So anyone has an idea why connecting it to this baby would or would not work? If not, I'm going full YOLO and just going to connect it. See what happens. Connecting an FTDI. So instead of using RS485, just using an FTDI on 5 volt. So I'm going to connect this one. So I removed the logic analyzer, and we already set the other one up. This one was change settings, serial COM11. So I'm going to the device manager, see what extra ports I've got. Now I connected the FTDI. So the 340 was the RS485, so the other port is the COM6. So I'm adding a new putty window. So a new putty window, connecting it to port 6, setting this one to 9600 baud. If you have an actual ground instead of a complementary signal, yeah, but where do I obtain the ground from? And actually I was using the ground just as I measured it from the device. So I was using the B signal, the D minus. So setting this one for COM6. So I have 2 windows now. So COM6 is my FTDI, and COM11 is my RS485. There's only one thing, since I'm only able to read the data, I'm not able to interact with the data. So if I'm connecting this one to the ground, and if I connect the other one, now I have to to the RX. So I connected both. Are you able to see it? And I type A. There's actually an A popping up here. So if I do not have an RS485 in this particular situation, I'm able to, and I don't think this should work. No, this does not. Might, would this work? No, it would only work one way. So you can actually cheat for data exfiltration. So the ground was not properly connected. So the other way. No, no, only one way. But Chrissy, you should be able to read the data that the device is outputting. So you do not have the 485 yet, so then you will be able to interact properly. But this gives you a head start of being able to already see what commands are being sent to the device. So this was my little tutorial on how to use the UART, how to use the 485 dongle. Let me switch to the other screen. So microscope view. So this is 485 dongle. This is the FTDI dongle. Played a little bit with the logic analyzer. Is it both in RS485? What is in RS485? Arun? I just set the PuTTY to a serial UART standard, so connecting yeah, it's only one way. So you connect I made some notes. So the A is the TX on the RS485. And A is D plus, and the B is D minus, which is the ground. So since it's a TX on the RS485, did you connect the RS4 with the UART or no? This I connected the 485 directly to a UART, not to another 485. Ah, okay. So it's since we measured that it was like a positive voltage, we used the data, the B1, like the D minus, as a ground pin, making it no longer differentiate and leveling it out as a UART. So connecting two PuTTYs, one with the RS485 and one with the FTDI. It won't work that way. What does not work? Okay. Yeah, you could be right. So maybe be careful and wait for the TTL. But I've tried this and it worked, at least for mine. Yeah, true. Okay, thanks for the safety warnings. So better to get like 485, but we try this, and in this situation it did work. Yeah, it does. Yeah, that's why I did use, so in a real device it gives 12 volt, maybe up till 24 even, but I did use the multimeter to measure the signal here to see if it was like safe to use the device, but yeah, always be careful with floating grounds, and yeah, always be sure, always measure to see what happens. I suggest we play a little bit with the M5 stack. Anyone, any suggestions on what to do? So, like maybe set up two devices on RS485 and have them communicate with each other and see if we can like eavesdrop on them. Yeah, these are dangerous streams because it will always make you buy stuff. I have that as well if I look at other people doing funky stuff. Like Joseph is lasers. Yeah, let's do lasers. I like your idea. So never worked with lasers. Let's see how lasers work. Oh, okay. Oh, I'm very excited about it. I will show you my other logic analyzer. So this is the DS Logic, and it has 16 channels. And the cool thing, who did you offend, Arun? You did not offend me, for sure. So this is the oscilloscope. So you can hook it up to each other. And now you have like a new device that allows you to have a dual channel oscilloscope. But there's also, I do not have all the other parts. Yeah, absolutely. It would not be a great idea to brick this, as this is a preparation for a stream that she will do in July, I think. We really value your input. That's why this is a collaboration and not me knowing everything. I do not know that much, but I try to fiddle and see how things work. And if there's people with more knowledge, always correct me, please do. So not offended. I would be offended if you would not say anything. So thanks, Arun. Really value it. But we were going to do lasers. Why isn't this working? I have no idea. Oh, it is working if you put it like this. So lasers. Where's the lasers? So these are the lasers. Laser RX and laser TX. Okay, so I suggest using these ones. So this is an yeah, never look in the laser beam with your remaining eye. So these are the atoms. Because those are cheap, let's use these instead of the other one. So what we can do is, like, there's a button in here. So are we able to somehow communicate with each other? And before we're going to do it using laser, we're going to do it with a cross cable. Yeah, yeah. The most important aspect is like wear a helmet, a safety helmet. So what I did is I took one of the cables apart and I made a mess. So where is this is probably the one. So this is, yeah. So if you look at this cable, one has like yellow, white, nothing. Nothing is where VCC is, and ground. And we do not want to connect the VCC to each other. So we're going to connect these devices together using serial communication, using an old-fashioned cross cable. So these are connected. And now we're going to connect the devices. Yep. So, doing one. So, before working on this, I probably need to flash it first. So, this one has a serial port, and now somewhere on my desktop there should be one M5 stack thing. I think it's in my folder Meuk. M5 stack burner. So this is the one. Oh, move. Okay. And I will put it on the big screen again. So screen. So M5 stack burner. And we know, due to the serial port device manager, that this is COM3. And if you're doing this on a Linux machine or on a Macintosh, it will be your /dev/tty USB 0123 or tty acm0. So this is what it will start. So we have an atom, and we want to work with UI flow. There's different versions. So yeah, take this one for instance. Download the software. And now I'm burning it. Burn failed. Okay, that's cool. COM monitor. COM3. Maybe reset it. Okay. There's an API key, so it is all properly flashed. Try to flash it again. Burn failed. So maybe I need to reset it. So remove it from the power, press the button on the side, insert it. Will this help? Burn failed. Okay. For some reason this is not working. So let's find out what the correct procedure is for doing so. So open a window. Hold on. Okay. Flash M5 atom. Okay. Maybe I can open, and if you want to join me searching for a solution, if I need to press a button or don't press a button or whatever, this is all new to me too. So COM port 3, 115.200. So this is showing my API key. So if I press reset, it will show my API key again. If I hold the reset button, nothing happens. If I restart the session, this is COM11, it's not COM11. Cancel. Okay, COM3, save settings, open. Okay, so turn on the device, you see a logo, you need to click the right to select a mode. Okay. Oh. Restart session. So can we somehow make this a little bit more smaller? Source community, when we are going to get new firmware. Okay. Change settings. Appearance. Change. Set it to 28. Maybe it's a little bit more readable. Reset. So M5, when are we going to get new firmware? Something. This is the okay. M5 burner. This there. Okay. this one. Burn. Yeah, this would not work if I open two COM ports. Burn. Okay. Having a little bit of a hard time on this one. This 145 matrix. Fatal error. Oh, this is too big. So maybe I need a smaller one. Should just have read the comments. Okay, burn. Yeah, okay. The new firmware is too large for the atom. Okay. Are we done yet? Burn successful. Hard reset. And now it's blue. Switching lights. So I'm closing this one. Taking the other device. COM monitor. COM7. Burn this one also. Burn filled. Maybe I need to burn. COM monitor. This is still set for COM7. Okay, so I need to quit the software to make this work. Okay, I have a new one. So not the latest one. Did I get this one? Download. Oh, this is the core. I should not download the core. I need the atom. So go back to the atom and select the 5.3 matrix. Burn. Okay. So switching atoms in the software is not possible. Note to self. Should report this so they can fix it. Oh, we can do that. Try to see if we can run the new software over the older one. Let's see if we can make that work. Okay, close. So taking the newest software, 5.1 matrix, burn. No. And if I take the 5.1 without matrix, no. No, newest does not work. Okay, so two devices. And if we go to the COM monitor, what will it show me? If I reboot it. Waiting for download. Okay, what I need to do now is probably connect with my phone. Does this work? So if I remove this one, connect it, COM7, it's waiting for download. So if I boot it, network connected. Okay. Something is happening. And this is like stuff that I want to document to see how it really works. So what I did, was already like create a OneNote to see like how stuff works, how you can document it, how these devices work, what the addresses are, how the keys were set up. Like this is the calculator, these are the hex values. Are you able to see what I see? Yeah, you are. How to set up the cat ears and the GSM shield, and so I'm trying to document for myself. I'm using OneNote for it, but you can do whatever you want. So for some reason it is doing something-ish. Hey Jan, leuk dat je er bent. So what happens if I remove the power and I press the side button and I insert the power? I remember that I had to configure these and connect them to my local network, and to do that I first need to log into the device itself. So that should show up like M5 something. But for some reason, comport COM7. What are you doing? Waiting for downloads. We have an atom, and the atom, let's take a light version then. Burn this one. So on some parts it lacks some intuitive guidance for it. taking you through my pain. Hey Nazar. I hope I pronounce it correctly. Hey, Chiller One. Okay, so hard resetting, burn successful. So we're watching me trying to flash the software on the M5 Atom. So see what the COM port is telling me. No, nothing much. So reset this one. Still doesn't do much. Maybe someone can help me find out the correct procedure to flash these. I have done it before, but don't know where I'm making a mistake now. So if I quit this and I open Putty. Hey Pete! So this is COM7. COM7 I think. So if I press reset, waiting for download. I think it is trying to burn will not work now. Close. Still trying to flash the latest software. Now try another one. I saw that the guys at M5 Stack were busy with making it possible to be able to flash it more low level. Atom Quick Start UI Flow. Yeah. Okay, burn successful. Let me look here. Close. And go to COM monitor. Okay. Go here. M5 getting started with UI flow. Okay. Might able to scroll back here. Okay. So that's docs. Come on. Docs.m5 stack. Quick start. Okay. Quick start. Atom. M5 stack. Docs. Okay. Go here. Atom. Docs. Where's my docs? Fuck. Cases. Platform. UI flow. Quick start. Atom. Download M5 beta flashed UI firmware referring. Press and hold this one. Plug in the power supply. Okay. Press this one. Hold it. Will be green. Let it go and will be okay. And if I now go to close COM monitor, what will happen? Nothing much. Go back to the documentation. It will be in Wi-Fi configuration mode. Yeah, okay. So, this is my now switch over to the webcam view. Come on. Microphone view. So, this states M5 stack. So, clicking on this one. So, M5 stack connected. And now I need to browse to 192.168.4.1, and this will give like a connection on how to set it up. So we'll need to find my network. Connect. And now I get a Wi-Fi connection successful. Resetting the device now. And And now I've got an API key. Okay, this is cool. So let's copy my API key. Okay, if I reset it, now I broke it. Let's see if we are able. Go back and see if this Wi-Fi X point is still available. It is not. So I assume that this might work. So going back to UI flow, M5 flow, going to 145, copy, and now connecting to this one, which is a atom matrix, and let's make this one green. Okay. Am I able to connect to it? It is connected. Okay. So this one is connected. That's cool. Let's add another one. Okay. And now I need the second cable. Connect the other M5 and I need to press the button, insert the USB, wait for it to run yellow, and now I should be able to connect to it. Using M5, and now I should be able to go to the website. This is COM port 3. Where are you, Putty? Open. Resetting it, and this just shown me go. Is this another one? So the other one, yeah, API key. Okay, so I need this one again and change the API key. So this is the API key. Set this one to orange. And okay. Oh, no, this is not correct. So I need to. This is an atom matrix. Connect. So is this working? connected. So two devices, both connected. So this is so two UI flows. Are you able to see it? No, you are not, because I'm on the wrong screen again. So that's screen view. Okay. So what are we going to do? We are going to make serial communication. So insert this one, make them connect to each other. Where are you? Like this. Okay, so two devices. I need something heavy to put on top. Okay, are you able to see the two devices? Yeah. Okay, so there's a button here. So I create one hardware, and this is IMU, no. RGB, no. Event, yeah. So if button A was pressed, something needs to happen. So what needs to happen? I need to send something via the serial port. So I'm going to advanced and going to UART. So UART, and I'm writing a number in UART. So writing a number in UART1, I think. Yeah, sure. Write number 1 in UART1. Then I create a loop. So loop while forever, and I'm going to read the UART. So now I need a loop. So that's a loop. I need logic. So if something happens, do this. So if UART done. Read all. Read one character. Yeah, but what character? If write line, read, write raw data, read line. Oh, I might need to set it up. That might be convenient. So set it up, set the UART. For 9600 baud using UART1. So write number 1 in UART. So if you read one character, where is this character stored? I think that needs to go somewhere else. So I think I need to make a variable. So create variable, and this is input value. So I have an input value, set input value to read one character. Okay. If, and now I need to compare something. Logic, if something equals to something, if my input variable equals to, and now I need a number, math I think, yeah, this equals 1, then I need to do the RGB and set the color to green, white. Okay, perfect. And then we need to wait. So wait for 2 seconds and then copy. We need outside the loop to set this one to black. Perfect. We need to turn them off again. So the code is set the device, set it to 9600 baud on UART1, and if we press the button it will send a 1 to the other end. So we can also include copy this. So if the button was pressed, we choose another color like red. So this entire thing turns red. So if I'm running this code, is it running? And I press it. Is it done yet?
Door van papa luisteren? Ja.
Connecting.
Wat rustig.
Trusten. Upload. Maybe your device is offline. I see some. This is connected to this one. Check it again. Connect it. Run my code. Latest firmware is 145. So if A was pressed, so this does not do anything much. So if I remove this one, will that help? Okay. Run code. So this is this. Do it once more. Press the button. No. So press the button. Needs to be yellow. Leave it. Connect to the access point. Okay. Connected. Go to the website. No, not the Google. 192.4. Okay. Select my network. configure. Resetting device now. Connecting to M5. Please update for better experience. What was the software that we installed? Close. 1, 4, 5. But we were not able to install this. Burn. No. Okay, too bad. Okay, go back and run the code. And if I press this, nothing happens. So let's remove this. Run. If I press this, remove this one, run. Upload code failed. So this, as soon as it's finished, should give a blue screen. Come on. Check the device. This is not raw C code. See the raw C code of this and check. No, it's a Python code that you will see if you click on the other one. So connected, run, and now it's blue. Okay, and I press the button and it will be red. So I'm adding this one, run, press, does not work. And if I add this one to set the baud rate up first. So why is this not working? Do I need to set this to UR2 maybe? Upload. Yeah, it is like Windows. So for some reason UART is not working. So maybe we should just skip UART and go directly to the lasers. Adding so are we able to use the lasers? Where are the lasers? Light, infrared, Makey, relay. Hard, thermal. Laser not here. Dark, infrared, external light. Standard degrees of freedom, RFID, finger, pH, hub, AD, button, trace, weight, servo, Makey, environment. Maybe need to scroll up. That's art. Cancel. Communication, ESP now, HTTP. Easy IO, read pin, PBM, UART, I2C, execute. I don't understand why the laser is not in here. Okay. Are we able to make this easier by going to Arduino? Not something. Maybe look at my ear. At the documentation, so go to M5 stack, go to yeah, store might help me. Module, no. What is it? Base. Unit. Okay, there should be laser here somewhere. Maybe I can just search for laser. So these are the laser modules. So how do they work? Laser units, feature, communication, TX. More information, no. Product document. Easy loader. Schematic, UI flow. Okay. Well, we can do that. So go back to the UI flow. We need to set up a UART. One empty. And this is okay. So the pins. I need documentation of the atom. I hope you are still liking this, as it is okay, that's atom. Go to document, and this one has oh, this is the atom light. It's not the atom light. Go back, atom matrix, document. So this one has BPS, G26 and G32. Okay, so we need to set this to and we need to know what the pins are of this one. Oh, but this is not. That's odd. So 26, okay. So this was the transmitter. So the transmitter, I'm looking at this screen now. Come on. So this one is here, and we need one here. So, well, that does not work as I was expecting it. This needs to be UART and needs to be set to 26 and 36 to 9600 and use one character. Okay, so that should do it. Switch this one to the other screen. So when button A was pressed, they said write a line. Okay, let us write a line. So this UART, write a line at UART1. So write a line, and this is A, B, C. Okay. And then we need a repeat. Yeah, the example, I can show you what is really happening. So I need to go to the other. So if you look here at the microscope on the bottom, and I need to you see on the bottom there's G26 and G32. Okay, so I made a mistake. This is G32. Those are the pins for the serial port. And I'm transmitting. So I'm transmitting, so that means there's ground. So that's the pin next to 5 volt, so 26. So 26, this is actually the only important pin. So 26 is responsible for the transmitting. So this will transmit the data over the laser. So adding this one and adding so not much laser beam yet. So whenever I press an A, ABC is transmitted over the laser. And since this one is only transmitting, I don't have to do anything with this one. So I can just remove this one because there's no interaction, it's only half duplex. So this one is let me do it the other way. So copy, delete, copy. So I'm setting this up, making the let go red, send the data, and maybe slow it down a little bit. So wait a second, and then turn it back to blue. So running this. Oh, and oh wow, this is in fact a laser. So pressing, and now something is being transmitted, and it really is a laser. So you can see in my hand that there's actually a laser beam. Okay, that's cool. So press will become red and it will transmit. Okay, that's one side. So now I'm going to the other one. you connect and you disconnected setup from the UART block now. Example, yeah. So the setup is only setting up the UART and setting the pin, and the button A1 is a separate one. It's like an interbase program. So now going back to the other program. So going back to the Laser RX example. So let me show you here. Go back to the screen view. So sorry for not being able to show you the screen earlier. So set up UART, paint the screen blue. If button A was pressed, send red a red message, write line ABC, wait for 1 second, and set it back to blue. Okay, and now the other one. So looking at what the code for that one might look like. So this is reading the data and showing it. So that will be a little bit different. So if we look at the receiver one, has the other pin. So there's like a pin. Look here at the bottom of the device is in nothing 5 volt and ground, while the other one has nothing out 5 volt and ground. So that prevents you from mistaking RX and TX. So connecting a Grove cable to the M5 stack. Okay, connecting this one, maybe shorter cable. Do I have a short cable somewhere? Yeah, take this one. Okay, so connect the receiver for the laser to the other M5 stack, which is disconnected. How does this work? This is connected. Now connect the other USB. Might need a bit of tape somewhere. So put this one here and use the Laserbeam like this. Okay. So the code. Take the code to the other screen. And now we're setting up the UART again. So go to Advanced, go to UART, go to Setup. And this was 26. And we need to have like the atom, and the atom was 32 in this case. So RX is 32, correct? 32, yeah. So that's UART 1, and now we create a loop. So that's loop. For repeat. Is it like a structure loop? loop, repeat. Okay. Okay, repeat math. Logical. We have like a true, yeah. Repeat while true. Okay, whatever. Need an if statement, so a logical statement. Logical if. We need an RGB one. So it's hardware RGB. Take this one. So the default for this one, it is off. And if, now I'm going to go back to advanced. Oh, back to advanced. Go to UART. And now we need to see if, and that needs to be, what is it, logical, I think. Logic, if, yeah, something is something. If the UART remaining cache is larger than 0, math at a 0, in that case, copy, paste, it will show a smiley. Okay. Run code. Oh, it needs to, yeah, and after it will return back to the original setup. So do we still have a connection to this one? So I need to verify the API key. Connecting. Yeah, connected. Run the code. Oh, I might need to know that this one is doing something. So make a dot in the middle. Okay. Run. If remaining cache is greater than, so what is happening here? UART. If the remaining cache, well, true. If remaining cache is UART1, remaining cache is greater than, oh, it needs to be red. That's what needs to be happening. So then I need to create a variable, and the variable is going to be called YOLO. So set YOLO to, we need the advanced UART again. UART read all. And now we can even create another function, so another logic. So that's if, and that needs to be logic, I think. If something equals something, if, and it needs to be my variable. So if YOLO equals, and now I need math, like something like this. A, B, C. Will this work? No, will not work. So I need a string text. Oh, that's a different function. Okay. So I need to go to text if YOLO equals ABC, then show this one and maybe wait for 1 second. Okay, run. Execute. Okay. So why is this not working? So this is the RX. Oh. I don't understand why this is showing up. Restart. And I need to put this one a little bit higher, so you see both. UART TX26 is 32, and this is 32. Where's the documentation? G32, 26 and 32. And this said sending ABC. Okay, 26, 32. So it's a receiving. So while true, if UART remains is greater than 0, means there's stuff in the cache. Set the value to read all. Maybe this is a text. Convert to string. Replace if prompt. Decode, reduce, convert to string. Do I need to make it simpler by not sending a create write line? Can I make it more simpler? Write line, wait a second. So what if maybe look in the Python view. Yeah. Well, true if UART set YOLO if YOLO equals, then do this. So this should only work set YOLO to read all. So if I move this, it should only have a dot. But it does not. So instead of text unit, I think I need to remove the power from this one. So this is okay. The device was stuck. Okay. Yeah, now we get a dot. Now put the original spot back. Run. Code executed successfully. You are the remaining cache. So maybe it's the text function if replace. What other functions do we have for the UART? Read line. So I'm reading a line instead of reading all. Run. Okay, moving this dot here to see if my code is actually working, like the printf of M5 stack. Maybe reset it. Run. Yeah. Maybe add a pause. Oh, there's already a pause in here. Can I fixate? The lasers to not get blind myself. Okay, one. So this one should go here. This one should go here. And this one. Okay, can we simplify this maybe even a little bit more? By not looking at the actual stuff. So if the remaining cache is greater than 1, then read all. So deleting this UART, read set remain cache, read all, and then I'm showing this one, and wait a second. Okay, put this one back in the middle. So reset it. Okay, and now running this one. Okay, pressing this one, pressing this one, pressing this one. Ladies and gentlemen, we have lasers. Okay, so we are able to at least see if a laser is sending stuff. So we should be able to read the communication as well. Yeah, might be, but the might be able to print the data. But the issue was that the M5 stack was not reset and not updated, so I was just still looking at old code. So what I can do, that might be a little bit more fun, is do we have an M5 stack here? Yeah, we have one. So instead of using this one, we're going to replace it with another one. So first I need to update the code on this. So we're using an atom at the TX side, and we're using an core on the other. So am I able to flash this one? So let me remove the other one, so that I'm sure that I'm flashing the correct one. Okay, go back to the, oh, where are you? Here, M5 stack. Now I need to go to the core, and I need to go to UI flow and taking the same. Okay, burn. So I'm now burning the core software. And now we're able to print the text on the screen, actually. So we're setting up laser communication between two M5 stacks. Okay. So what do I need to do now? Reset. UI flow. Setup. Now this is like the configuration of the M5 stack. So Wi-Fi via access point. Now it states that this is the device that I can log into. Let's do that. Wi-Fi, search for this specific device. So there's a M5 microscope. There's this one. So connecting to it. Unsecured network. Okay. Next. Okay. So what can we do here? App. No. M5 go. So reset. Okay, so if you click the middle one, you will get an API key. So let's just leave this one. So clicking here, saying this is a core. My API key is 8F01B845. Okay, connecting. So now I'm no longer able to do this. So what I am able to do is set the communication. I am able to create a label, title, I think, a label it is. So adding the label here. And this label will be data. Okay. So how do I set the label? Label. Top maybe. UI, label, yeah, okay. So I set the label to whatever, okay. The label set to waiting for data. That's a good one. Yeah, which one? Which pins are you connecting to? I'm not connecting to any pins now, but now we need to go to the documentation. Good one, Crazy. Good one. So core, and core has just one connector. So go to this one, button speaker, the Grove, and the Grove connector is ground, 5 volt, GPIO, so that's 21 and 22. Okay, and so from a perspective of this one, where's the connector? So that's ground, 5 volt, and the first one next to it is 21 and the other one is 22. So let me go to this one. So the move this one a little bit here. So that's ground, 5 volt, the TX. So TX 5 ground, TX will be 21. So TX will be 21 and this will be 22. Okay. So there's only one connector here. So okay, if we run this one, it would state waiting for data. Waiting for data. Okay. So let's see if we can click on the label and make the font Comic Sans. Yeah, it's not really Comic Sans, right? Okay. What's this? Oh, it's creating new datas, new labels. Data. So need to get rid of this one, put it in the trash. Okay. So this is Comic Sans. Perfect. Okay. Run it again. Waiting for data. Cool. So waiting for data. So show my other screen, screen view. So what I'm going to do now is wait while true. Then I'm going to wait for the remaining cache. Then I'm putting the read all in YOLO, and then copy paste I'm putting, oh, need to remove this. How do I remove this? Can I set YOLO? And now I need to have my variable, this one, YOLO needs to be in here. Okay. Oh, and this does not work like that. And I need a timer. Timer for 1 second. And after that, it's waiting for data again. Maybe this override stuff. So insert the other one, run the code again. This is funny. Okay, so now we know why it didn't work. So let me show you. This is really funny. Microscope view. So that's why you need to debug. So we created our own printf. Look at our data. There's a character return line feed in this one. So comparing it to ABC won't work. So can we somehow strip the character return line feed? Are there some texts? So convert to string, maybe? Can try that. Run. What else can I do? Uppercase, length, trim spaces on both sides. Okay. Don't know if trim spaces also applies for character return line feed. Let's see what happens. Yeah, that actually worked. So B. Can I decode it? Maybe even. Yeah, cool. Oh, detail, string. Can't assign it. Retry. Okay, run. Did I break it? Yes, I did. So if I move this to Python, so YOLO is UR, data is text, get text waiting for data, strip decode. I think it cannot decode when there's no data. Must be something like that. Why don't you use send line? I was using send line, right? Write a line. Or don't you send a line, yeah. What else can I send? UART. Write line, write character. Yeah, we can do this. So and it's gone. So need to solve that one. So why is this one crashing? So I think we need to decode this one, and we need a piece of logic. If text, can I see like the length? Yeah, if the length, oh, that needs to be logic again. Logic, if something equals something, if the length of the variable YOLO is larger than mathematical 0, then a variable set YOLO to decode of YOLO. Will this work? Okay. Yeah, this solved it. So what happens if I take my laser and put this one somewhere? So I'm aiming it for the laser sensor. We still be able. All your API keys belong to us. Someone used my API key. Nice. I really like to know who did that, because this was something that I was hoping for it to happen. So instead of people calling my mobile phone, I'm sharing API keys, I'm sharing more stuff. So someone dare to admit he used the API key remotely. Cool. But this works, so you can transmit. Nice. Cool. This works, so Crazy, thanks for your suggestion to do laser communication. And it actually works quite well. What I'm wondering is, what is the top speed of communication? So can I do like line of sight? Where's my... Can you flash it again to all your API keys to belongs to us? I want to take a snapshot and put it on Twitter. So that's unit. Now let me search for laser. Okay. Response frequency. For burning it. Why don't we just try and set it to the highest speed possible? So this is one, and this is the other. Okay, see if this still works. No, that seems a bit too high. So 1 1. Yeah, cool. Thanks. Taking a snapshot here. Always cool if people in InfoSec are being hacked. So 115200 and go to 115200. Okay, see if this will happen. Error. Run. Is it only possible to send over 9600 baud? Okay. Slow and save, I suppose. Yep. Okay. Could maybe duplex the stuff by using 8 lasers. Oh, okay. Well done, Joseph. Well done. Okay, it's about 12 o'clock. So this is a 4-hour stream. So I think we should end it. So I leave you to it. Had a lot of fun. So I hope you did too. Yeah, was cool. Cool to have you on the stream, Chrissy and Joseph. Really value being here as well. Looking forward to your streams and your projects that you're going to build, as you're doing quite some fun stuff. So yeah, thanks, and up to the next one. Enjoy. Have an amazing weekend.